guys, welcome back. So now let us look at a little more like complex example. In the first example, we looked at a simpler example and we were able to use both the methods, like two different methods to find the derivative, although both methods are kind of the same methods, but they still require like different work patterns, right? So guys, in this example, as you can see that it is a little more complicated. What makes it more complicated? One of the things is there's an the exponent is 3/2, so obviously we cannot directly use, or we should not try to use any product rule, or I mean we cannot use any other rules right away. Then guys, there's something more going on even inside. Even this function x squared plus 4 is inside the radical, so it seems like there's more than one composition or going on in this particular example. So how can we handle it? Guys, for the first thing that I like to do when I'm working with these type of examples is, and once I figure out that this is an example which can be solved only using the chain rule. So what I first do is, since for chain rule or any of these rules, guys, we still want to have them in the form x to the power n so that we can apply the power rule in one way or the other. So the first thing what I do is, instead of writing this as a radical, guys, I just rewrite this as x squared plus 4, and instead of writing it as a radical, what I do is I write them as an exponent, so that now it looks like to me x to the power n, and I highly encourage that you should also do that as well. Minus 3x squared and then raised to the power 3/2. Okay, so guys, from here I have my like kind of own way of doing it, which is not anything different than what the chain rule basically suggests. Guys, what I do is I think of this whole thing inside the parentheses as a big X, right? And then I have this x to the power n, x to the power 3/2, and I like that is perfect candidate for a power rule. So using the power rule, so f prime of x, the first thing we have to do is you just write the derivative of the whole thing. So derivative of the whole thing is just kind of writing the derivative of x to the power 3/2, which is n times x to the power n minus 1. But I don't have just this x, I have to write this whole thing, whatever is inside the parentheses, and which is x squared plus 4 raised to the power 1/2 minus 3x squared and raised to the power, keep in mind, let me use I used a different color, so I'll close with the same thing, raised to the power n minus 1. Guys, 3/2 minus 1. 3/2 minus 1 is 3/2 minus 1. What is 3/2 minus 1? Is just 1/2, right? So I will just write 1/2 right here. And then guys, there's this extra piece. We have to multiply by the derivative of the inner piece. I have to multiply by the derivative of this. So that means in this case, I have to multiply by the derivative of this and the derivative of this, right? So in parentheses, I have to do the derivative of this first. Guys, again, now looking at this function by itself, we cannot calculate the derivative of this function. This is still a composition of functions, and what makes it a composition of function is that it is raised to the power 1/2. So in this example, we again have to use the chain rule to write the final derivative. So to write the derivative of this guy, guys, this is pretty simple. We don't have to do really anything about it. It's just the simple power rule. This guy, guys, again, I'm going to treat this as an x, and then I'm going to first write the derivative of x to the power 1/2, which is 1/2 x squared plus 4 raised to the power 1/2 minus 1, which is going to be negative 1/2. But I still have to multiply by the derivative of the inner, and the derivative of this inner without the 1/2. When I say derivative of the inner, it is just what is inside the parentheses. Now, when I ignore this 1/2 and just focus or look at the piece or quantity inside the parentheses, I'm looking at x squared plus 4. This can easily be done using the power rule. Derivative of x squared is just 2x, and derivative of 4 is 0, so I just have to write 2x. Guys, that takes care of this whole thing, right? This radical, which we changed to 1/2. Then minus derivative of this. Derivative of that is simply 3. You bring the 2 in the front, so it is 3 times 2 is 6, and you have to subtract 1 from 2, that is just to the power 1. I don't have to write that 1. Guys, that is it. We are done. First, let us go back and see what we did. We changed this to 1/2. Why? Because we want to have everything into the power, some exponent, so that we can easily apply the power rule if possible. Guys, we treated this whole thing as an x, and we use the power rule on this. we wrote this whole thing. We didn't do anything with this inside this first parentheses. We just rewrote it. All we did was we bring that 3 halves in the front, which we would do with the n, and then we subtract 1 from the 3 halves. Guys, this piece is done. Then one has to multiply by the derivative of the inner, and this is going to be the derivative which is inside the parentheses. But inside the parentheses, there's 2 pieces. One of the pieces can easily be, we can easily find the derivative of this using the power rule right away, which is just 6x. Minus will stay. But this guy, we cannot just, in a one step, we cannot just write the, or we cannot just come up with the derivative. So one has to kind of, again, looking at this, it looks like we still have to use a chain rule type of a process for this one. Using the chain rule, again, we treat this whole thing as an x. It's x to the power n. You bring that n up front, then this x squared plus 4, whatever is inside the parentheses, right? Guys, look, here this whole thing was inside the parentheses, so I wrote the whole thing. Here only this is in the parentheses, I wrote just that in the parentheses, raised to the power n minus 1, 1 half minus 1, which is negative 1 halves. And then we had to multiply by the derivative of the inner, and the derivative of inner is just 2x. So guys, this takes care of that piece. Now let us see if we can simplify a little bit. So f prime of x, we cannot do really much with this, so it can just leave it as 3 halves. Then inside the parentheses, I have, well, I cannot do really much with this. It's x squared plus 4. If you want to keep the final answer in radical, that's fine. So I wrote it back in the radical because I don't have to do anything further with it. And then minus 3x squared raised to the power 1 half. That takes care of this. Make sure that I'm closing with the same color of parentheses. And then guys, times. Here we can simplify some things. 2 and 2 will cross out, right? So we'll be left with just x times x squared plus 4 raised to the power negative 1 half and minus 6x. Guys, this is the final derivative of this function, which is not too complicated. You just have to understand the basic idea of using the chain rule, which is treating this whole thing as of x using the power rule, multiplying by the derivative of the inner. In this case, we had to like do some extra work on this because this is still a candidate for a chain rule. Okay. So guys, example 2 is done. I'm going to still show you a lot more examples using the chain rule because there is a possibility where we can have a quotient rule inside the chain rule as well. So they can just kind of show up together with the product and the quotient and the chain rule together. So I'm going to show you a lot more examples. Guys, till then, practice these and look at these carefully. And then I'm going to show you more in my next videos. Till then, take care. I will see you next time.